Hello friends, today our topic is de Broglie's hypothesis. Okay, the wave nature of electron was first proposed by de Broglie. Okay, the wave nature of electron first proposed by de Broglie. According to de Broglie theory, all moving particles have wave properties. All moving particles have wave properties. Wave property, okay, these wave properties are important only for particles of small mass and high velocity. Okay, this wave properties important only for particles of small mass and high velocity. Okay, from Planck's quantum theory, E equals to h nu. This is one relation, E equals h nu. We can also write this one hc by lambda. Okay, nu, this is nu. This nu equals to, okay, c by lambda. This is one relation. This c value we are substituting here. Nu value substituting here, c by lambda. This is equation 1. Okay. In similar way, Einstein's mass, okay, and energy relation, mass and energy relation, okay, that E equals to mc square. Okay, this is equation 2. According to Planck's quantum theory, E equals to hc by lambda, and according to Einstein equation, E equals to mc square. Okay, from equation 1 and 2, from equation 1 and 2, okay, we can write like this: hc by lambda equals to mc square. hc by lambda equals to mc square. Okay, here this c and this square is cancelled, then lambda equals to h by mc. This is one equation, de Broglie's wave equation, where c is the velocity of light. Okay, c is the velocity of light. When velocity of microparticle is v, okay, then de Broglie equation is lambda equals to h by mv. Lambda equals to h by mv. Here m into v is nothing but the product of mass and velocity. Okay, that is nothing but momentum. Okay, we can also represent momentum, okay, with a p symbol. Here lambda equals to wavelength. Okay, this lambda equals to wavelength. V is velocity of light. M is mass of electron. Okay, h is Planck constant, and mv, product of mass and velocity, or p is equals to moment of particle. P equals to moment of particle. Okay, this is we are calling as de Broglie's wave length. De Broglie's wave length or de Broglie's wave equation. Okay, next, how this verifies with Bohr's theory, Bohr's atomic model. Okay, how this is verified with Bohr's atomic model. Okay, verification of Bohr's atomic model by de Broglie. How de Broglie verified Bohr's atomic model, that we will see now. Here there is two types of waves possible. There is two types of waves possible. Two types of waves are possible for an electron moving around the nucleus in a circular path. Okay, two waves are possible for an electron moving around the nucleus in the circular path. Okay, one is standing, okay, or stationary or non-energy radiating wave. A standing or stationary or non-energy radiating wave. Okay, yes, here we will see how the electron is revolving on the wavelength. Okay, see now, when the electron of wave, okay, its wavelength can be accommodated in Bohr's orbit only if the circumference of orbit is an integral multiple of its wavelength. Okay, that is nothing but 2 pi r. This is circumference 2 pi r, that equals to integral multiple of its wavelength. This is one relation. 2 pi r equals to n lambda. 2 pi r equals to n lambda. Here, okay, when this 2 pi r equals n lambda, this electron wave of wavelength, okay, it is like this, it is like this in the form of wave. Okay, this 2 pi r circumference equals to its wavelength when the electron is revolving in a circular path in the form of wave. Okay, this is wave phase. Here what happened, lambda equals to 2 pi r by n. N is here integer, here n value is n is integer or whole number, integer or whole number. Okay, we know that from de Broglie, lambda equals to h by mv. From this both relations we can write h by mv equals to 2 pi r by n. 2 pi r by n. Okay, when these two are simplifying, we will get one relation, mvr equals to nh by 2 pi. Okay, this relation already we know. This is Bohr's angular momentum, mvr equals to nh by 2 pi. Okay, it proved that, okay, this Bohr's model is verified by de Broglie. This is Bohr's angular momentum with the help of this de Broglie wavelength, and okay, here this circumference equals to its wavelength. Okay, wave of wavelength equals to its circumference. Okay, from these two relations we proved that okay, this Bohr's atomic model with the help of de Broglie's relation. Okay, now when this 2 pi r equals to n lambda, then only the electron is revolving around the nucleus in a circular path in the form of wave. Okay, this is wavelength. Okay, the distance between two adjacent crust. Okay, yes, next one. Here, hence de Broglie theory and Bohr's theory. Okay, de Broglie's theory and Bohr's theory are agreement with each other from this relation. Okay, next second condition, second possibility of wave. Okay, it is non-stationary or energy radiating wave. Non-stationary or energy radiating wave. See, if the circumference is bigger or smaller than lambda, okay, bigger or smaller than lambda, okay, the wave train will go out of the phase and the destructive interference of waves causes radiation of energy. How this when 2 pi r, the circumference is not equals to n lambda, the wave is forming like this, and it is not in the continuous wave, no, no. It is not in, okay, in the form of circular path. It goes out of the phase, okay, the wave or the electron in the form of wave, it goes out of the phase, okay. Then it is a destructive interference of waves causes energy. Here energy released due to this destructive interference, okay. Hence such orbit cannot exist. This orbit is not exist, okay. Here what we can say, in this case 2 pi r equals to does not equals to n lambda. 2 pi r does not equals to n lambda. Hence such an orbit, okay, cannot exist, okay. This is out of the phase, the wave electron, okay, electron of wave not in a phase, it comes out of the phase, okay. Next, this is two possibilities of moving electron. Next, important few relations are there that we will see. Different forms of de Broglie's wave equation. Different forms of de Broglie's equation. Okay. Here we have to get a few relations. Okay. First one is the number of waves. The number of waves in an orbit is equals to n. The number of waves in an orbit equals to n. Okay. And second one is the number of revolutions of an electron per second in an orbit, which is equals to velocity of electron divided by circumference. Okay, velocity of electron by circumference. Yes. And one more relation, okay, the relation between kinetic energy and wavelength of moving particle. We are writing lambda equals to h by mv. This is, we know, de Broglie wavelength, okay. But what we have to write here, the relation, okay, we are getting from kinetic energy, okay. We know kinetic energy formula K equals to half mv square, okay. Here mv we need, mv square equals to, okay, 2ke. Here both sides we are multiplying with n, okay. Then m square v square equals to 2 km. Both sides we are multiplying. Here m we are multiplying. Then we are getting this relation. Then mv whole square equals to 2 Then mv equals to this square, okay, it becomes in right side, it is root over 2 okay. The same value, this mv value we are substituting in this formula. Then we are getting one new relation, okay. Lambda equals to h by mv value we are substituting this. This is square root of or root over 2 KEM. This is one relation. What is the relation here? Okay, kinetic energy and wavelength. Kinetic energy and wavelength of moving particle. Okay. Next one. Next, we are taking another relation. Okay. Let a charged particle like electron be accelerated with a potential V. Then the kinetic energy equals to E into V. Okay, E is the charge of electron and V is the potential. Okay, V is potential. Then kinetic energy, simply we can write Ke equals to E into V. E into V. Okay, the same relation here. Instead of Ke, we are writing lambda equals to H by, okay, root over 2 into E into V and M. This is one more relation. The relation is charge and potential and wavelength. Okay, when we are substituting these values, H is Planck constant here, okay, E is charge of electron, M is mass of electron. When we substitute this all values, okay, then lambda equals to, we will get 12.27 by root V angstroms. Okay, when we are substituting here, H equals to Planck constant, okay, 6.625 into 10 to the power of minus 34 joule second. E is charge of electron, okay, M is mass of electron. These all values when we are substituting, okay, we will get this relation now. M is mass of electron, 9.1 into 10 to the power of minus 31 kg. Okay, the similar way, the de Broglie wavelength for an electron in a given orbit, here also we can find one more relation, that equals to 3.33 into n lambda, n angstroms. How we got this value now? See here, we know already lambda equals to 2 pi r by n value. Okay, simply here we know r value we are writing. What is r? R for first orbit of hydrogen, okay, 0.529 into n square by z angstroms. We know this relation. Okay, then this r value we are substituting here. Then r equals to 2 into pi value 3.14 into r value, this one we have to write 0.529 into n square, z equals to 1, here z equals to 1 for hydrogen, okay, n square by, here n is there, n angstroms. Okay, here n square, here n is cancelled. When we are simplifying this value, 2 into 3.14 and 0.529, we will get approximately 3.3, okay, 3 n is okay, here n is there, and angstrom. This is the relation. Okay, this is the simplification for this one. Okay, now we will see all the relations in de Broglie's wavelength. Okay, we will see what is, first we will see lambda equals to h by mc. Okay, we can also write that velocity of light, we changed velocity of electron mv, and mv is momentum, that we can write h by p. Okay, then this mv value we can write like this, h by square root of 2 KEM. Okay, and also we can write okay, h by root of 2 EVM. Okay, these all are relations for de Broglie wavelength. With the help of these relations, okay, we will solve easily whatever given numericals. Okay, thank you children.